Hello. Welcome to Successful Open Source Engagement Patterns, which is sort of, over the course of its preparation, turned into the aphorism talk. Welcome. A couple quick disclaimers here at the front. I do not know everything. I may be wrong in places. So please ask questions. Please raise objections if you disagree. And please do offer your own insights. So I'm talking about patterns. And generally speaking, when you talk about patterns, you're often talking about design patterns. And in the general sense, they're referred to generally as some general reusable solution to a commonly occurring problem in a given context. In this case, the context we're dealing with is engaging with open source communities. So some really simple examples of patterns from more familiar domains. So people often talk about software design patterns, things like singleton, factory, builder, et cetera. Or development methodology patterns, such as continuous integration. But what I'd really like to talk about today are open source engagement patterns. And the basic reason for this is there are a lot of things that are sort of misunderstood about open source. Some people think it's just about licensing. Some people think it's just a software development methodology. But the truth is that open source is fundamentally a collaboration pattern. We happen to use it a lot for software, but mostly it's about effectively working together in groups across organizations to solve problems. So one of the reasons I wanted to give this talk today is that networking is sort of new to open source. So many network vendors and customers are relatively new to open source as a collaborative pattern. And we are all going to get substantially better outcomes in OpenDaylight if we are all successful at collaborating more effectively with each other. So I've put together just a basic list of a few groups of open source engagement patterns. So first is forking is evil, except when it's not. And under that, you get things like Upstream First, commit early, commit often. Another one that comes up often is flocking, not blocking. And this has a lot to be, has things under it like being constructive and not obstructive. Talk around actual code whenever possible instead of arguing about slides. The organic adoption of best practices, and bottom-up is almost always better than top-down in open source. Doing the work. So there's a real tendency in organizations to try and figure everything out before you start working. And in open source, it often works better differently. You start by doing stuff, making mistakes, doing more stuff, and then making fewer mistakes. Additionally, when you're talking about doing the work, resources follow interest. And of course, the very popular code is the coin of the realm. And the last thing that's actually an incredibly powerful open source engagement pattern that is in some ways not obvious at first is help others. That actually ends up being crucially important. So the first one I want to talk about is forking is evil, except when it's not. So open source is a collaboration pattern. It moves very quickly. When you fork an open source code base, for whatever reason, you're falling out of collaboration with the mainstream. And this is, you wind up with several kinds of evil kinds of forking that are fairly common. So you will get a deep temptation in many companies to make a copy of the repo in an open source for an open source component and work on it internally. All of your internal people will collaborate on something internal to the company. This ends up being really bad because you discover when you want to go back and rejoin the community that you've fallen out of sync, that you've not actually successfully collaborated with other people. And so it creates a problem for you. In fact, most long-lived branches, and there are some exceptions to this, like release branches, where if you've got an emergency fix, you can put them there. But most long-lived branches end up being pretty bad. And we'll talk a little bit more about this when we get to Upstream First. Acceptable kinds of forking. So short-lived topic branches on individual developers' machines tend to be good and useful things. I've actually, said on a number of occasions around sort of this forking is evil. I'll get to that in just a second. So commit early, commit often. So every bit of local work a developer does is a small fork and a small movement away from the collaborative whole. And this is inevitable. There's nothing actually wrong with it. But it's best to try and keep those deviations as small as possible, and to do small thematic commits that are easier for folks to review and read, that are easier if you start getting off track for people to point out that you've gone off in some crazy direction. If you do a very, very large chunk of stuff and push it, number one, it's hard for people to review. Number two, it's more likely the world has moved on without you. And number three, it's more likely you've done something profoundly stupid, which all of us do as developers. Essentially, many eyes make all bugs shallow. Small changes mean small mistakes. So upstream first. So when you keep an internal repo in your company, you are inevitably creating a long-lived fork. Long forks are extremely hard to close. We've actually seen a couple of occasions of people wandering off and doing things that were potentially interesting, but they were so long-lived that they were effectively unmergeable. The world had changed too much on them. And you get no feedback in the community. So you get very late discovery of your mistakes when you keep an internal fork, when you don't practice upstream first. And just to be clear, because there's sometimes misunderstanding, when I say upstream first, what I mean is when you're working on an open source component. Obviously, if you're working on a commercial component that for business reasons you're choosing to keep proprietary, that's different. But if you're working on an open source component, the way I will typically put this when talking to my internal developers is, I don't ever want to see a copy of the code anywhere in the company except on an individual developer's laptop who is working on it. It shouldn't go on a server somewhere. It shouldn't be kept someplace where we can collaborate together on it. If you want to collaborate, collaborate in the open.
How do you run that internal build machine?
OK, that may be a little different. So this is kind of what we've talked about so far. We've talked about forking is evil, upstream first, commit early, commit often. So the next set of stuff I want to talk about is sort of the flocking, not blocking. So many companies and other organizations are used to building consensus before starting work. This is a very normal thing. You get together, you figure out what you're going to do, you measure 15 times, and you cut once. Open source tends to move very quickly. And there are a lot of participants with a lot of different interests. If you insist on fully meshed consensus before anyone moves, you get left behind. However, you do want to try and flock together as a group. So you do want to talk about things. You do want to review each other's code. You do want to work together. But you don't want to say, wait, stop, and prevent forward motion. This is sort of fleshed out a little bit more here in be constructive, not obstructive. So everybody in an open source community is trying to solve a problem. They're not always the same problems. And demanding that someone stop solving their problem seldom actually solves your problem. So if there is work being done, people are actively working on something, and you sort of pipe up and say, wait, stop! That doesn't solve my problem. Or, wait, stop! That makes my problem harder to solve. That typically is not going to be that persuasive to people. They have a problem they're trying to solve. But if you can come in and say, let me help you solve your problem in a way that actually is compatible with the problem I want to solve, that gets tremendous buy-in from people, generally speaking. The first, demanding that somebody stop solving their problem to solve yours, typically means that you put everything down. Worst case, everybody stops and they argue about it. That's not so effective. So when you look at ways to try and figure these things out, talk around code whenever possible. So design discussions are prone to miscommunication. And I'm not saying don't have design discussions. They're good. But if you can come up with concrete code that does something, and this therefore is somewhat comprehensible, it really brings clarity. I've had a number of occasions where I've gone into conversations about how things should be done, and there was just no agreement. And I pushed a little bit of code that did a chunk of what I thought we should do, and we all looked at it and it's like, oh, that was not at all what I heard you say. When I look at this, this looks reasonable, because the code is the truth. So if you can communicate your proposal with simple sample code, it's easier for people to see what you're talking about. And the working good is often better than the hypothetical perfect. So if you have a solution to a problem, and someone would like to complain that something is inadequate about your solution, that's fine. But if you want it done better, do it. So bottom up is almost always better than top down. So it's hard to actually see the real problems from the top. It's easy to convince yourself at the top that you have the real solution, because it's hard to see the real problems. So you're usually wrong that you have the real solution. And you can cause a great deal of harm by trying to force bad solutions down from the top. But at the bottom, it's easy to see real problems, and it's easy to experiment with real solutions. And if you're wrong, the harm is limited. And again, this doesn't mean that you don't think about big picture stuff. And it doesn't mean that you don't try and figure out big picture stuff. But it does mean that it's really easy to make big mistakes when you try and drive everything from the top level big picture down. Instead of saying, this is the big picture I think we want to deal with, let's start at the bottom working up and try and solve some of these problems. So, organic adoption of best practices. Real best practices solve real problems. So developers like solving problems. It's their primary motivation often for what they're doing. And developers like reusing off-the-shelf working solutions to solve their problems. It means you can move on to other problems more quickly. And therefore, real best practices that are clearly communicated and appropriately vetted tend to get adopted organically. If you find yourself trying to force people to do things, you've probably made a mistake. If you simply show, this is what we want, this is a practice I think is good, this is where you can see us using it, you should try it and see if it works for you. It starts working for more people. Eventually what you do is you look up and you discover this is the way everyone is doing it. Because it's a way that works, it's comfortable, and it's the way everybody else is solving this problem. So we've talked about forking is evil and how to maintain in collaboration. We've talked about flocking and not blocking, and therefore how to constructively engage in a way that moves things forward as opposed to obstructing them, for good or bad reasons obstructing them. And now we need to talk a little bit about doing the work, because open source fundamentally is about doing the work. It's about writing the code. So do stuff, make mistakes, do more stuff, make fewer mistakes. So mistakes are inevitable. Fail early, fail often, fail obviously. Because those failures, those mistakes that you make, will be small mistakes, they will be mistakes that are easy to recover from, they'll be mistakes that you can learn from, and you can proceed forward and succeed. The longer you wait to do stuff, the longer you wait to discover your mistakes. And foreseeing mistakes is really hard. I mean, how many people here have actually intentionally created situations where they're intentionally making mistakes? That's what I thought. How many people have actually made mistakes? That's also what I thought. So it's hard to foresee mistakes, but it's easy to make them. So you want to make them as small and as quick as you can. So resources follow interest in the open source. This actually came from a really interesting discussion that we had very early on. Just after the announcement of OpenDaylight, the technical steering committee was up on stage for a panel at ONS. And someone asked a totally reasonable sounding question. They said, how is the technical steering committee going to direct resources? And it was a perfectly reasonable question, but in some ways we were really taken aback because in the context of open source, it actually doesn't make any sense at all. Because nobody is in charge. The technical steering committee could actually not tell anyone to do anything. So if you want to cause change, you either have to write code or you have to convince someone to write code. So I'll give you a really good example of this. This was similar to the example that Neela mentioned, where the OVSDB plugin literally came out of one developer who came in with attempting the convince someone to write code strategy and said, I think someone should do an OVSDB plugin. And the response that came back, very well intentioned, was, that's great, you're someone. And so that developer actually started writing code, and we have this very vibrant community around that plugin now. And the other reason that question of the TSC was so strange is, even if a central body tried to direct resources, it only works to the degree that those resources actually want to do that to begin with. So even if the technical steering committee had decided it was going to direct resources, nothing that people weren't interested in working on was going to get done to begin with. Because if either the individual developer or their employer is not interested in doing something, it generally is not going to get done.
So what's the point of the committee?
The technical steering committee actually provides a framework for us to collaborate together as a group. And it provides a certain degree of accountability for how we are working together as a group. And that's most of what the technical steering committee actually does. So for example, the technical steering committee organizes the simultaneous releases. So the stuff that goes on the download page on OpenDaylight is the stuff that is the output of that simultaneous release process that the technical steering committee organizes. Projects can do their own thing, they can release on their own schedule, but if they want to be part of the simultaneous release, then they have to come along and participate. They have to play along and come do the milestones and get the pieces together and act as a community towards a common goal. And that container, that organization, is what the technical steering committee provides. We do other things as well, but that's a big part of what the technical steering committee provides. So, and then code is the coin of the realm. So at the end of the day, someone has to do the work, right? So if you want change, you've got to write the code or convince someone to write the code, as I mentioned before. And sadly, code doesn't actually write itself. So I did actually want to step back. There was one particular story I wanted to tell a little bit further back on the be constructed, not obstructive. And this is actually a story from the early days of OpenDaylight. So in the early days of OpenDaylight, there was some disagreement about how we should interface with Neutron. There were people who had different notions of what the northbound API. There were people who wanted to do multiple different Neutron plugins. And there was disagreement, there was debate, there was a lot of discussion. People thought that things should be done way A or way B, depending on where they were. And what finally ended up breaking that logjam was, regex boy, Ryan Motes, basically stood up and said, okay. I will do the work to make it easy for people to plug into the way, just talking the straight Neutron API northbound. We're not going to try and make anybody do it. We're going to make it easy for you to do it. So we're going to make it easy for everybody to plug into this mechanism. It was a very constructive thing. And rather than continuing to argue about how to do things, which in the best case scenario simply would have resulted in diverse solutions, what you had was people coming together around doing a constructive thing. And that ended up being intensely useful and valuable to the community. So I apologize. I've actually gone through these much faster than I anticipated. But what I would like to do if you guys, helping others. One last thing. Development is social. So we're all going to need a little help from our friends in the community. Our interests are not as clearly separable as we think they are. And this is a place where the OpenDaylight community has been amazing, right? There have been so many situations where you have seen people in OpenDaylight helping other people where there's no reasonable connection you can point to. I'm actually going to talk about a fair number of them tomorrow in our sort of war stories panel, where we're going to have the audience come into the room. And we're just going to share stories about the valiant things that people did in the course of getting OpenDaylight out the door. But this ends up being incredibly useful and helpful because every single person I'm aware of in this community has had somebody who has no reasonable causal link to their interests come in and help them, and has done likewise for other people. And that's really what keeps the whole thing moving forward together as a community. So, as I said, I moved through this a bit faster than I had intended. So what I'd like to do, actually, is sort of open it up to the audience and see if there are questions, if there are other insights or successful patterns that people have seen. A lot of this stuff flies very counter to the way we're used to working in corporations. And some of it sounds sort of almost fantastical to many people on first blush. So I would like to actually sort of see what you guys as an audience have for questions, comments, or insights. Yes.
You've talked about engaging with in-house developers and kind of indoctrinating them in this process.
Mm-hmm.
Can you talk a little bit more about the barriers to doing that?
Well, I mean, some of the barriers are institutional. So, for example, so how many of you who work for places, commercial vendors or other people who write software have experienced branching hell? That's what I thought.
Or the opposite, the fear of branching, because they come from source safe.
Because what?
Because they come from source safe.
Oh, that I've never encountered. That sounds magically interesting and different. So for those of you who have experienced branching hell, why do you think you wound up there? Anyone want to sort of give a point as to why you thought you wound up in branching hell? Yep.
People don't pull from upstream, they get divergent.
I'm sorry, what?
People don't pull from upstream, they let their code get divergent
Right. But why did they pull the branch to begin with?
because they don't want to be distracted by other people.
Exactly. And what sense of safety does it give them where they don't have to deal with other people? You know, why are they looking to not deal with other people? Yeah, it's control.
Code stability too.
Yeah, no, but the code stability comes down to an issue of control. And so it is, you know, if you're a development shop, and this is how we've all wound up there as a development shop inside a commercial enterprise, letting go of some of that control and actually working with other people can be scary, right? And part of it is you are concerned about build breakage, although there are lots of things you can do in an automated way today to protect yourself from that. And so a lot of the exercise of learning how to effectively operate in open source is about letting go of certain elements of control. You know, when you're working with other people that you don't control, that aren't being directed in directly the same direction, in exactly the same way you want to, it can be really scary as an organization. So you literally have to have a conversation about safety, how their feelings of safety and control, and about the benefits of actually continuing to be plugged in to the mainstream of that collaboration. And what I've seen, not only from Cisco, but from other organizations, because I've been working with people all over the community, is it can be very scary at first, and then you do it, and nothing terrible happens. And you do it, and something wonderful starts to happen. And then you kind of like it. And you sort of keep moving forward that way. So that's been some of the challenges and some of how we've sort of approached overcoming it. But yeah, it is definitely a challenge. It's not in the organizational DNA of most commercial software producers. Yes?
So when it comes to open source, can you elaborate a bit on the testing process? Like when the software is commercial, you know, there's like different phases, different releases. You have alpha testing, beta testing, and GA. So how do you get engaged? How can you get the community engaged?
Sure. I can talk specifically about how OpenDaylight does it. There are a whole wide variety of ways that people do it. The whole world is sort of converging in general directions on continuous integration. So the way we end up doing it at OpenDaylight is that every single commit that comes into OpenDaylight comes into a system called Garrett, where you do code review. And it doesn't actually get merged at that stage. It's staged for code review. And a verify job is run that checks the build, that checks a whole slew of tests against it to make sure that you haven't broken things with that patch. And then committers for that project come in, and they review that code. They look through it. They look to see if it's doing something that looks untoward, that looks like it's counter to the direction the project is going in terms of like the quality of the code. They make suggestions to the developer. It's actually not uncommon for the patch to spin a couple of times and improve. Once that patch is in a decent shape, then a committer merges it to master. And once it gets merged to master, it then goes through an entire new set of building master, testing master that happens automatically to make sure that nothing has broken in the course of that merge. Because there are a small number of pathological things that can happen where a patch may verify, but then the merge may have an issue to make sure things are good. Then part of what happens is we have many projects in OpenDaylight. We have 12 in the simultaneous release. And some of them have interdependencies between each other. So if project A depends on project B, every time a new set of the artifacts for project B are built as part of a merge, a job kicks off for project A that causes it to rebuild itself on master, rerun all of its tests, and make sure that it's still okay. So that if there is a problem due to that dependency, and that problem can be on either side. I've seen situations where a bug gets introduced by a pivot. It happens. That happens to be caught by project A. I've also seen situations where a bug gets fixed. And how many of us have not seen a situation where you accidentally depend on a bug in order to actually have something happen right in your code? You know, someone wasn't throwing the exception they were supposed to be throwing, and you silently wrote over it, and now suddenly you've got a problem because you're not handling that exception. And so it runs all of its tests. And this propagates through the tree of dependencies to make sure that all the projects that are dependent and transitively dependent are good. And eventually, at the end of this chain of dependency, you have our integration project. The integration project doesn't really build anything per se, it assembles. So it assembles all the pieces of the simultaneous release. It assembles them into the various release editions that we know we're going to be doing. And it runs much more extensive system test-like tests. It spins up a bunch of different systems that test them to make sure that things are actually going well and functioning. And so what you have as a situation is the patch comes in, we make sure it's good, we make sure it makes it a master good, and we test all through the line to make sure that we haven't accidentally introduced some disturbance in the system. And in the course of development, things break, and you fix them. Does that make sense?
Yeah, so how do we engage potential customers in the testing phase, right?
How do we engage what?
How do you engage potential customers into the testing phase, right? So I work for a provider, so if there's like a new release, a vendor will say, hey, you know what, it's like a beta test or alpha testing. Guys want to test it in your lab, and then same
So
process.
that's one of the things we actually are in the process of trying to figure out. We would very much like to engage more with customers in the testing phase and say, listen, for a couple of reasons. Number one, we'd actually like you to try it out in your labs. Number two, when you find things, we'd like to reintroduce automated tests to make sure that we don't regress on that, right? And so in that regard, and there's a certain class of thing that is not so much a bug that you find when you actually put things in customer hands. And that is, you hand the customer something, and it functions exactly as intended. But why did you intend that, right? It doesn't really meet your need. And that's a feedback of a different sort. Does that make sense? And we desperately would like that feedback as well. So no, we would love to see this trickling down into provider labs, into other people's labs. Ericsson has been kind enough to set up a testing lab. And we even have worked out, quote, a federated mechanism to help people so that you could, for example, set up some testing in your lab that was automated. So when this chain comes all the way down through our integration systems, you could have your Jenkins system polling to see that there are new images and could pull it in and push it through whatever testing you're doing in your lab. So you could sit here and you could be testing stuff that you don't want to let the rest of the world know for whatever reason. And you could come back and say, hey, that last build, it breaks this way. Please fix it. So, does that answer your question, or? Yes?
So I think everyone would argue that high-quality code reviews are important.
Yes.
How do you incentivize developers to spend their time and resources looking at other people's code?
It is a royal pain in the ass. And I say this as someone who's done a substantial amount of code review. I spend half of my life in code review, frankly. I'm a committer on controller, and I spend an incredible amount of time on code review. And part of it is social, quite honestly. I have had people sort of reach over and go, plink, 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 could you please go look at my patch? Right? It happens. At the end of the day, though, we're all trying to get across the finish line, and I don't think we've had a substantial amount of problem with people just being ignored. We've occasionally had small glitches. Christmas break was really bad for this. There was a bug number 3, one of the earliest bugs ever in the controller. Somebody went out and submitted a fix for it, I think December 26th, and it took a couple weeks to get noticed, and I feel really terrible about that. But we did get it merged. It actually also happened to be in kind of a sensitive place where you're looking at it going, okay, a little bit more test coverage before we merge that one. So these things do happen, but it's the same social incentive for why anyone behaves well in a society, right? So that would sort of be my answer to that. And I know it sounds sort of like I'm just reaching into my bag of open source pixie dust and saying it will be okay, but it seems to be working out. Yes?
So what are the best practices that you've observed and would recommend for the front-end process? Like determining what we should be doing, what are the requirements, and verifying that we're doing the right thing before we get to any of these
So,
engagement patterns, which are quite valuable.
well, here's the thing. So developers actually do care about end users. I know it sometimes doesn't feel that way as an end user, but we do, right? Because the only point in writing the code that we write is to solve your problem. And so you have a lot of people trying to figure out what the problems are and how best to solve them. And you have discussion that does happen. At the end of the day, resources do follow interest. So if there is some problem that comes in the front end and nobody's actually interested in working on it, it doesn't actually get done, right? There is no central committee that sits down and processes the requirements and prioritizes them and so forth, or at least not in any grand systematic way. You know, most.
But why not? I mean, isn't that something that's needed to make sure that
So there is a need for the presentation of those things. We would actually really love to, and I actually think that that prioritization is something that actually rightly, I think, comes from our end users. But at the end of the day, even if we have a prioritized list of requirements, which is something we very much would like to see coming in from our end users, someone still has to do the work. And that means that someone still has to care enough to do the work. Does that make sense?
Yeah, it makes sense, but is there a opportunity for a product management, or at least thinking of a corporate setting, a product management function and set of contributors that collaborate with the developers?
So I think there may be.
Go down this path because
Mm-hmm.
it strikes me as someone who's obviously coming at it from that
Mm-hmm.
perspective that we could reduce some of the timetable, streamline some of the activity by going through more of a filtering process up front versus figuring that out when it's delivered.
Right, no, I think actually there may be. This is not something you commonly see, but that doesn't mean that it isn't something you shouldn't see. And my challenge to you would be, and I'd be happy to talk with you after this, is let's see if we can get a community of people together around trying to gather, you know, to a certain extent prioritize, and somewhat also express the reasons for requirements, because it is, I presume that you're in product management. Okay, so how often have you gotten a requirement for a customer and then you need to go back and talk to them a little bit more about why they want it?
Well, that's not how well, I mean, this is a different discussion, but the idea is to be able to talk to multiple customers, synthesize the requirements, and then come up with a prioritized set. I mean, this is ideally. Meaning you're not just listening to what they say and do it, you're thinking about it, circulating with development. I mean, it's not a...
Yeah. But part of it is understanding, because I've often had things.
Is open source ready, though, to maybe expand the realm of possibilities in the front end, the way it works downstream with a little collaboration up front to get downstream?
So I would actually be really interested to see you actually pick up and explore some of that in OpenDaylight, because it would be new ground. It's not something that I've actually seen done so much. And I would be interesting to see what patterns are helpful and not helpful in trying to do that around open source. My guess is they're not quite the same ones you do commercially.
That's why I was asking you the question. I mean,
Yeah.
I sort of figured out that outside of the corporate setting, it's going to be different. But I'm just raising it because I feel that we need something like that to,
No, absolutely.
especially considering the momentum, the scale. I mean,
Oh, yes.
now the gap starts to get wider, right?
No, absolutely. So I mean, I
We can talk about it.
would absolutely love to talk with you about it afterwards. Yes.
On the topic of flocking.
Yeah, flocking.
Scenario where you've got two projects, both important. One is related to the next release, of helium. Another one that's actually, from a prioritization standpoint, something that only needs to show up, whatever
So basically, how do you make priority calls around resource allocation?
In terms of branching, isn't the only option to fork the project that's slated to release after agent? Because you can't technically.
So we don't have a single code base.
Oh,
We have right now we have 12 projects in hydrogen. We have 15 projects total. Each of these has a different source code base, source code repo. They build a bunch of relatively fine-grained modules. We're extremely modular. And most of those modules are of a pattern where you have an API module, and then you have a implementation module. And so even if I were to say, hey, I'd like to start a totally different implementation, it's going to take me a while. That implementation is a distinct thing servicing the same API. So it doesn't end up being a fork necessarily. Yeah, we actually also have 5 other project proposals that are public right now and others in the wings. So I would not be surprised to see us have an even larger number of projects. So it is that modularity that allows you to not wind up with deadlock situations like the one you described. So, other questions? Other insights? So, all right then. Thank you all for your time. I appreciate it.